know that when I went to therapy, they would do that. How do you feel about your parents' divorce? I'm sad. But they just stare at me like, and it like forces you. Okay.
And they like.
They can just sit there.
How would I go stare? I'm just like.
You can't. They're so much better at it.
What if they wanted you to save more and you just stood there and said nothing?
They either like smile at you and stare, or they'll like.
Right. And then you feel like you have to say something.
I know.
Okay.
Alright. Flip this over. I want to just put a couple definitions on the back. So you means union. Which is or. And what that means is one or the other or both. You get that? So like the union of two events. We'll start doing that Venn diagrams a little bit, but a union will be like where they overlap. It's part of it. This means intersection. Means and. I remember it like this. Like if you draw the A and the N kind of that way, it looks like the intersection sign. Capital A, lowercase n, they both look like the lowercase n. This looks like I'm trying to write it in some weird way. And then this bar means given. So anything after the bar is known to be true. For example, the probability of A given B would ask, what's the probability of A? If I know B is true. One, two, three, and then there's a fourth one. I feel like I'm going too fast. Getting very excited about that terminology. It'd be helpful if I turned that. Can't really do it. I don't know how to solve that problem. It happens in every class. I'm just like trying to hide the corner. And then there's one more. So if you see this, like, so A with a C up here means the complement of A. So we're going to go through 3 different ways that they can present the information to you. We're mostly going to focus on, let's just say that. We're not mostly focused on it. We'll focus on it. 3 different ways that they can present these to you. If you look at the packet, we got a table, we got a Venn diagram, and we got a couple that are just words where you make your own Venn diagram. So let's start with this first one. I know there's not questions there, so I'm going to write the question as we go. So part A, let's say I said, what's the probability of chocolate or man? I can't write that.
We do.
We're gonna pick a different example.
Riley noticed it immediately. I was like,
I can't even find another page. to remember here is you're going to add up the probability that A happens and the probability that B happens. But there's usually going to be some overlap where both of them happens. And if you just stopped here, you would have, the times when they both happened, you would have counted in this spot and you would have counted in this spot. So you will have double counted the ones that were in both. And so you have to subtract it out once. So you're only counting it once instead of twice. Does that make any sense? Yeah. Okay. So if I look at this chart, I'll write out the formula in a second, but how many, just count, forget the probability like this out of this, just how many males are there? 28. How many people prefer chocolate? 33, right? So right now we're at 61 out of 50. Like that doesn't make any sense. But this 18 right here it was counted twice. This 18 is in that 33. This 18 is in that 28. It can't be in both. That's like double counting it. So we have to subtract it once. So we're gonna go 33 plus 28 minus the overlaps. So minus 18. So the probability here would be 33 out of 50 plus 28 out of 50. Where am I getting the 50 from? That's like the total, right? Like the big total. And hopefully this is a good example of why you have to subtract it out, because right now we're at like 120% or something. Like that doesn't make any sense. Minus the overlap. So I need to subtract out the 18 that were, because those got counted in both slots. So now I get a much more reasonable answer, which is 43. It's the worst thing I've ever written down. Yeah, so like some people will just do this and like you can avoid it until the end. You gotta put it at the end. But some people just go 28 plus 33 minus 18. Okay, that's 43. But don't forget to put the 43 and 50. If you tell me the probability is 43, that's not right. You know? So let's say the probability of, alright, I have to think through how this is gonna look. Vanilla or female. You guys try that. So yes, the formula will be given to you. Yes, you don't have to memorize it, but hopefully you understand what's going on, like why you're trying to figure out that a little bit. Hopefully that helps you just remember. When you're adding, the order doesn't matter. But the subtraction has to be that there. But I would just stick with order. So the probability of vanilla is 11 out of 50. The probability of female is 22 out of 50. But then this slot right here got counted twice because that's the overlap. That's females who prefer vanilla. So you counted 5 in both slots. You gotta undo that. So you gotta subtract that overlap. So that'd be 28 out of 50. How many had 20 out of 50 before I got to this? Questions? I can't do it anymore. I don't
Almost
get
even half.
13.
Yeah, that
I
was
know.
even halfway there.
Alright, let's do the probability of chocolate and female. So there's no formula here, it's just how many people prefer chocolate and or female divided by the total one. It's not supposed to be a tricky one. There's no formula up there for this one, you're just reading the chart. So how many people prefer chocolate and or female? 15. How many people are there? 50. So that's all that is. given stuff. Well, no, let's do one more. What's the probability of vanilla complements? So what that means is find the probability that it's vanilla, and then do what? Yeah. You just repeated the question to me. If they're two complements, what do their probabilities have to add up to? 1. So find the probability that you do get vanilla and subtract it from 1, which I know is what you're trying to say, but it's just funny. So how many people prefer vanilla? 11 out of 50. So the complement is 1 minus 11 out of 50. So it's like everybody else. So it'll be 39. Yes. Do you see where I'm getting it from? So how many people do prefer vanilla? 11. And so everyone else is the complement. So you have like, if I were to draw it, how many people are in the box? 50. How many people prefer vanilla? 11. The size of that box is the complement. So it's everyone else. So it'll be 39. Does that help? 50 minus 11. Yeah. Alright, so I don't want to write this because I'm running out of room and I want a couple more to do. But let's just verbally, what's the probability of male complements? Well, 22 is not a probability, be careful. 22 out of 50, right? Okay, you see where I'm getting that from. Okay. Alright, now I want to get into the given stuff. So the probability of, let's say, chocolate given male. There's a line there, not a U. So, everything after the bar we know to be true. So I know that I'm only looking at males. So what we do here is basically this. Nothing matters except the male column. So if I know I'm in the male, given it's a male, I'm only going to look here. Out of the males only, what's the probability that someone prefers chocolate? Well, how many people prefer chocolate? 18. How many males are there? 28. So it narrows your focus and tells you you're only looking in this one spot. Let's say the probability of female given vanilla. So this would work the other way, like sideways. Female given vanilla. So I know that I'm only looking at vanilla. So I can cover up everything else. So when I'm looking at just that, because I know I'm in the vanilla row, what's the probability that it was a female? So how many females are there? 5. How many people are total in that row? 11. So 5 out of 11.
Why is that one different from the first one? Because you used total male last one. Is it just
It's because this thing after so this is male, so then, male is a column, so I'm looking up and down. But this is vanilla is a row, so I'm looking sideways. So it's switched. Do, male given chocolate. So I know that chocolate is true, so I only look at the chocolate row. That's the only place I'm looking right there. And I want to know the probability that it's made. So how many total are in the chocolate row? 33. How many of them are male? Try this. See. As soon as you get it, I'm going to ramp up the difficulty. So vanilla complement means I'm only looking at the ones that work vanilla. So I'm going to cover up the total too. So it looks a little bit like that. So how many people are there total in vanilla complement? 39. And how many of them are female? 17, right? 15 and 2. So you got 17 females up here and 2 down there. You go with that? I mean, I don't care if it's not. I just care that you were saying that.
Also, just do there would be 39 people for the compliment, and then 22 minus 5 because that's what making it.
Yeah, that's the same thing, right? Alright, questions on the top part though. So let me just write some questions for the second part that I'll have you do. Try those 5 right there. So this means the C is choir and the NC is no choir. I really know what to do with that, so that's not choir. first two, A and B. I'm gonna get A and B right. So A is 44 out of 480. B is 436 out of 480. I'm gonna get those right. And then just see where we're at. Right? Like, did you have a question that you were just saying? You like the old one that answers. You guys know that stuff?
Yeah.
Just play well. Is Coach Price pleased? My coach did well. B, so senior and no choir. So you're just looking, that's just like, that's and, so it's where they both happen. So that's just this one spot right there. So there's no overlap, there's no subtracting out, there's just like, where did these two things both happen? So you're just reading the chart basically. Don't overthink it. Alright, the probability of senior given choir. So senior given choir, so if I know they're in choir, I'm only looking here. What's the probability they're a senior? Well, there's 41 people in choir, 23 of them are seniors. This is 23 out of 41. Only of that one. Questions? I'm only going to wait for them. Alright. Probability of choir given senior. So flipping it around, so now the thing I know is senior, well that's a row, so I'm looking this way now. And now what's the probability they were in choir? Well, there were 459 seniors. Only 23 of them, only 23 of them were in choir, so 23 out of 459. Alright. The last one, probability of choir complement. So that's just basically not in choir, right? So isn't that just 439 out of 480? Okay. We're gonna skip this one because I'm gonna leave some of this for like a more about tomorrow type of thing. Go to the first Venn diagram one. So restaurant, notice what type of food, got burger and fries. So I snipped these questions I snipped the graphs from God. I was like making up my own questions about them. I didn't. I meant to snip this part out, but I didn't. But just let's look at it since it's there. Are burger and fries mutually exclusive? No, there's overlap there, right? So, have you guys seen Venn diagrams before? Do you know what this is? Like brand new, or just like I've seen it? I've seen it. So, what this means, just to talk through it. Everything in this box has to add up to 100%. So, this is like all the possible outcomes. 20% of the people didn't order a burger or fries. Right? They ordered something else. 55% of the people ordered a burger and fries. 15% of the people just ordered a burger without fries. And 10% of the people just ordered fries without a burger. The difference in a Venn diagram is that number is not counted twice. So in the table, if you're looking at this row and this column, that number's in this row or this column and this row. In a Venn diagram, it's not. So you don't have to subtract it out. So it's a little different when you're doing the calculations. So let's go through some questions here. Let's say what's the probability of, let's just say what's the probability of burger. And these will just be decimals, 0.6, 0.5, 0.7. So how big is the burger circle? No. So 15% is the people that ordered a burger but not fries. How big is the actual burger circle? 7. So that includes this whole deal. This 0.7. So what's the probability of fries? 0.65, right? That's the entire fries circle. What's the probability of burger complement and fries complements? It means I got neither burger, I didn't get a burger, and I didn't get fries. 0.2. That's the 20% that's like the white space in the box, right? Alright, probability of burger and this means I got a burger and I didn't get fries. That's 0.15. Yeah. Just as important, you understand like what the notation is telling you? Burger and not fries. So then flip it. What's the probability of fries and burger compliments? That'd be 10, right? Or 0.1, yeah. So I got fries and I didn't get a burger. So that'd be 0.1. What's the probability of fries and burger? Overlap. That's the overlap. That's the 0.55. Alright. What's the probability of fries or burger? This is different than the last one because again you don't have to subtract out the overlap because they've already taken care of that for you. That overlap is not in this table twice. It's only there once. So fries or burger, that means one or the other or both. So one is 0.15 or the other is 0.1 or both 0.55. So you just add up these three numbers. The other way you can think about that is what's the probability that I didn't get fries or a burger? It's 0.2, and then what's 1 minus 0.2? 0.8. So you can kind of get to it that way too. Alright, two more here. The probability of fries given burger. So only looking at the burger circle. So let's start there. How big is the burger circle? It's 70. The burger circle is this one here. So if you add up those two numbers, it's 0.7, right? In that burger circle, what percent of it has fries? That's the 0.55. You see where we get those two numbers from? And then divide it out. I don't really care what the division is. We just stop there and say, everybody knows how to type division in the comment. So then you guys try this. Burger given fries. Just honest. So the given part, this is the part we know is true. So we know we're looking in the fries circle. So start there. How big is the fries circle? 0.65. And then we're like, okay, just in there, what's the probability that there's burger also? It's 0.55. Then you divide those. Everybody got those set up, okay. Alright, we'll keep on with this tomorrow.